Let's talk about brushless motors, which are these little guys that you might see attached to a quad or a drone to make it fly. Essentially, what is a motor? A motor is just something that turns electricity into motion, in this case, rotary motion, because it will spin when you power it. And basically, these motors are brushless, which just means that there is no actual physical contact between the rotor and the stator inside of here. Everything is powered by magnetic induction. So if I take this apart, I can show you what I mean. So brushless motors are made up of two parts. There's the rotor, which is what will spin. It has some magnets on it on the outside, and then there's the stator, which has coils around the inside, around a bearing. All right. So how it works is you will power the motor. You power the coils through these three wires here, and basically it's the three-phase brushless motor, which just means that there are three sets or three groups of coils. So even though there are 12 individual coils, most of them are grouped, so like they're actually physically connected. It's the same wire that's wrapped around, and that means when you power one of these leads, it will power that group of coils. And essentially, when you power coils and you put current through a coil, it generates a magnetic field in that coil, and then that magnetic field will move the magnet in the rotor so that the magnet will align with that magnetic field. And then basically what you do is you will change either the direction of the magnetic field or which coils are activated so that the magnets will continue to move, and you just do that very, very fast, and the motor spins faster and faster and faster. That's essentially how brushless motors work. Now, like I said, this one has three-phase, which just means that there's three sets of coils, but there's not really a reason that you can't make different numbers of phases. You can have one phase, two phase, you could have like 8 phase, 9 phase. I think 3 phases are the most efficient, and there's kind of a trade-off between the number of phases that you have and then the cost of the motor, like the amount of wiring you have to use. But I was interested in how motors kind of work, so I decided to make some simpler motors, which are 1 phase, 2 phase. I'm going to talk to you about a 2 phase motor today and my design for it. So this is the design for my 2 phase motor. You can see that there's a stator with two sets of coils, so these two are connected and these two are connected. And then there's my rotor, which has 6 sets of magnets inside of it, and then the pillar in the middle, and then there's just bearings in the top and the bottom so that this thing can connect together and it can actually spin properly. Now I'm going to talk to you more specifically about the design and the design file. So like I said, here's the stator, and like I said, these two sets are connected, and also these two pillars, the coils on them, are connected. So that means it's just the same wire that's wrapped around each set of pillars. And then here's the design for the rotor, which has just holes for inserting your disc magnets. I'm using neodymium disc magnets, and then there's 6 holes for them. And the only thing to note is that when you're actually assembling the motor, you want to have alternating pillars or alternating magnets. So let's say this is a south-facing magnet, or the south pole is facing outwards, then you want the north pole facing outwards here, and the north pole facing here. And then there's a magnet on this side, which you want the north pole facing here. And then there's 2 more magnets where you want the south poles around here, just so that they're alternating around, so that as you're varying the current or the poles that's created by the coils, it's just aligning with magnets, so it causes it to spin. Let me show you the reason that there's 6 inserts for magnets, but there's only 4 pillars, is that you don't want all of the magnets to be aligned at once, because then your motor can get stuck. So basically I'm using an extra set of motors so that when one pillar and magnet is aligned across this section, you see that these ones are not aligned with anything. So it's not in equilibrium, I guess you can say, which just means it's going to want to continue to move around. So if I were to disable these coils or to change the polarity of these coils, then this would still want to continue moving rather than being attracted here. Hopefully that makes sense. and then we'll get into the design of the circuitry and stuff in a second. So for the circuitry that actually drives the motor, you want to be able to do two things. One is to power each coil individually, so separately, and then the other one is to be able to switch the direction of the current that's flowing into either coil. So the reason that you want to do that is because, let's say current is flowing in one direction, it means that the north pole is in the front of the coil and the south pole is at the back. If you switch the direction of the current, then the south pole will be at the front and the north pole will be at the back. So it just gives you more flexibility in actually trying to switch those poles so the magnets will move around. So to power my coils, I'm using a chip called the L293. Mine is actually the L293D, but essentially it just allows you to power two separate coils and to control the direction of current that you're sending to the coils using a microcontroller. In this case, I'm using an Arduino. So the pinout for this chip, essentially, you can power. I mean, there's two sets, right? So there's a set for coil 1, 2, and then there's a set for coil 3, 4, is how it's labeled on this diagram. And each one has its own power supply, so I'm putting 12 volts into both of them. You could vary that if you really wanted to. And then you also have your enable pins. So there's the 1, 2 enable and then 3, 4 enable, and then you can basically power that from an Arduino, and just basically if you give it a high signal, it's enabled, and if you give it a low signal, it's disabled. Also, you can use like a PWM signal to control the speed. So how much current is flowing, which controls the speed of the motor, essentially. And then there is another group, which is the input pins. So this is how you will tell your chip what direction you want the current to flow in. So if you send like a high signal to 1 and a low signal to 2, it will spin one direction. If you send a high signal to 2 and a low signal to 1, it will spin in the other direction. Or the current will flow in the other direction, which will make the coil generate magnetic field in the other direction, which will make the coil spin in the other direction, if that makes sense. And then finally, you have your output pins, which are these set over here, which basically allow you to plug in your coils. My coils are these things over here. But you plug in your coils and they will get power. So like you plug your 2 leads of your coil into 1, 2, and then the other coil into 3, 4, and then based on the inputs, it will put current either in 1 and out 2 or in 2 and out 1, if that makes sense. And then there's just these collection of ground pins over here. I'm just using those to connect my power supply ground and my Arduino ground, that they're all getting the same reference point. And yeah, I mean, it's not a super complicated circuit. It's just you need to have your pins in the right order, and then you have to have your microcontroller set up to send the signals at the right time in order to actually get the motor to spin properly. So far I've done a whole lot of talking, but now is the moment of truth. I have wired everything, connected the Arduino and the motor driver, and now all I have to do is turn on the power and try to make it spin. Now you'll notice that it doesn't really start spinning right away, and often I have to give it a little bit of a push to get it going in the right sequence. But once I do that, it should continue to spin for, well, forever, essentially, for as long as the power is on. It's kind of cool. I don't know how long you want to watch this for. Feel free to skip. Obviously, it's not going very fast. Part of that is because of the Arduino timing. I've set it to pause between each stage for like a hard-coded number. This little thing is supposed, well, I haven't connected it yet, obviously, but it's the Hall effect sensor that is supposed to be able to sense the position of the actual like permanent magnets inside of inside of the rotor, and I can use that to get more precise timing and actually make it spin faster, because right now it'll only ever spin at a constant speed. But yeah, that's a functional two-phase motor. Kind of just a proof of concept, but I think it's pretty cool. And I'll see you in my next video, I guess.